Hello calculus students and general seekers of truth. Welcome to the video lesson on finding the derivative power rule or using the derivative power rule. So before we dive into this, I know you can look this up on textbooks or online. This is a very common rule. It's used all the time, but we're not just looking to apply a formula. We're also seekers of truth. So I want to show you at least where this rule comes from. And in order to see where the rule comes from, let's build up to it. Let's start with this basic example. Let f of x equals x cubed. Find f prime of x. In other words, find the derivative. So let's begin with the limit quotient definition of the derivative. So this is the standard definition. The limit as h approaches 0, f of x plus h minus f of x. And then let's apply the particular function that we have in mind here. So we have the limit as h approaches 0 of x plus h cubed minus x cubed, all of this over h. And then I'm going to cube this, so this is x plus h times x plus h times x plus h. And doing so, I get the limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed minus, still I have this x cubed right here, all of this over h. Right. Now you can see here some nice things we'll be able to cancel. This is x cubed and x cubed that we can cancel out, and then what we can do is factor out an h in all of these terms here. So we pull out our h, and what we have left is 3x squared plus 3x plus 3x h, sorry, because that's a square, plus h squared, all of this over this h, and we're taking the limit as h approaches 0. So it gets even better at this point. Now we can cancel out our h's. Then we can make the substitution. We can take 0 and plug it in for both h's, and we end up with 3x squared. So this is the derivative of x cubed. The derivative of x cubed is 3x squared. And we did that using the limit definition of the derivative. So now I'm going to kick it up a notch, and we are going to find a slightly more challenging derivative. Okay. So now instead of using x to the third, I'm going to find the derivative of x to the 80th power. And so this is a serious problem. So we start out again with the definition of a derivative, the limit as h approaches 0 of x plus h all minus f of x all over h. And then we apply that to this particular problem. So this is x plus h to the 80th power minus x to the 80th power, all of this over h. And don't forget your limit as h approaches 0. Now, we could manually work this out by hand, but that's going to take a very long time, so we are going to apply the binomial theorem. If you don't remember what the binomial theorem is, click the link in the description of this video, and there will be a further explanation of that. But if we apply the binomial theorem to x plus h to the 80th, what we have here is 80 choose 0 times x to the 80th power times times h to the 0th plus 80 choose 1 times x to the 79th power times h to the first power. Okay. And this pattern is going to continue. It's going to be 80 choose 2 times x to the 78th power times h squared, okay, and so on. And we're going to continue until we reach 80 choose 80 x to the 0th power times h to the 80th power, and then we still got to subtract this x to the 80th power. Okay. All of this is over h, and then we take the limit as h approaches 0 of all of that mess. Now let's do some simplifying here. Well, 80 choose 0 is just 1, x to the 80th is x to the 80th, h to the 0 is just 1, 80 choose 1 is 80, x to the 79th power, h, plus 80 choose 2 is some gigantic number that I am really not going to bother figuring out at this point, x to the 78th, h squared, and so on. We get to this point, 80 choose 80 is also 1, x to the 0th is 1, and so what we have here is h to the 80th power minus x to the 80th power. That's this term right here. We still have left over. And all of this, once again, is over h, the limit as h approaches 0. Now here comes the fun part. We have an x to the 80th in the front. We have a negative x to the 80th. That's gone. Now what we're going to do is factor out an h. And you see here that all of these terms, starting with 80x to the 79th h, all the way down to h to the 80th, all of these terms has at least one h in it. This is h squared, the next one is going to be h cubed. So we can factor out an h. And what we end up with, let me get my limit set up here properly. Okay. So what we end up with here is 80 x to the 79th. This h here is gone, plus 80 choose 2, x to the 78th. This h here just becomes, this h squared just now becomes h to the 1st, because we already factored out an h, plus dot dot dot, and we are going to end with h to the 79th. Because again, instead of h to the 80th, we lose one power because we factor out an h. These two terms cancel, and now we can substitute in 0 for h. And if you look at the terms that we have remaining, 80x to the 79th, plugging in h in, plugging in a 0 here for h, that's gone. And all of these terms in here also have a factor of h. So when we plug in 0 for h, all of them go away as well. So all we're left with now is the derivative of x is equal to 80 times x to the 79th power. And there's a lot of messiness here, but the point is that most of this actually goes away. A lot of it just gets cut down all the way down to 0. So this really is a precursor to what I really want to do, which is prove the general rule for the derivative of a power function. I'm going to end this video here, and I will start another one so that we could have a fresh video for that. Thank you for watching, and have a wonderful day.